Hi guys, welcome to Vijay Knowledge Tree. Our topic is top 50 Python theoretical interview questions and answers. I have collected 50 plus Python theoretical interview questions. What I have till now, I have attended the few interview questions and what they asked then collections in Python, the related questions, and I wanted to share with you. And if you are enjoy this video, please subscribe for more videos, so you can get more videos also. And then give the comments, whichever is uh, want to know the more on Python and what you have doubts in Python also. Please give the comments in the below, and this video will helpful to many members who are is looking for job and who are is looking for to get a job, and please share to them. Let's get started. The first question is, what is the Python? Python is an interpreted high level general purpose programming language. It emphasizes code readability with its notable use of significant indentation. It supports multiple programming paradigms, including procedural, object oriented, and functional programming. Why Python considered a high level programming language? If you say what is the Python means, so Python is interpreted high level, you are saying the same, the definition of the Python. But the interview may ask the question is, Python, is Python considered a high level programming language? You can say that with the reasons I have given the in this slide. You can tell, and you can prepare also. A high level programming language is one that is designed to be easy for humans to read and write. It abstracts away of the complex details of the computer's hardware, allowing programmers to focus on coding logic rather than low level mission operations. Let's see what are the reasons why we are calling high level language. The first reason is abstraction. Python abstraction abstracts away many of the details related to memory management, hardware specifics, and system architecture. For example, you don't need to manually allocate and deallocate memory or worry about registers and memory addresses. Python's garbage collection automatically handles memory management for you. And the second reason is readable and concise syntax. Python syntax is designed to be readable and easy to understand. It uses indentation to define blocks of code, which enhances readability and reduces the need for explicit delimiters like braces. In other languages, here is the simple example comparing Python to C++. So the first C in the C++, we can write for int, or we can initialize the value 0, and we can give the condition statements, and the next is the increment, and the with braces we can open the increment like count I, like that we can give. But if you want to use in Python directly, we can give for I in range is the function with the function of range. If you give like that, and 5, the 5 integer I mentioned here, so it starts with the 0 1 2 3 4 and print I. So in this example, Python syntax is more straightforward and easier to read, especially for beginners. And the third reason is built-in data structures and libraries. Python comes with built-in data structures like lists, dictionaries, sets, and tuples, which simplify data manipulation and reduce the need for manual implementations. Additionally, Python's standard library includes modules, and functions for a wide range of tasks such as file IO, web development, and data analysis. This means you can accomplish more with fewer lines of code. Fourth reason is dynamic typing and interpreted nature. In Python, you don't need to declare the data type of variable explicitly. The interpreter infers the type at runtime, making the language more flexible and easier to use. Also, being an interpreted language, Python executes code line by line, simplifying the development and debugging process. And fifth reason is focus on developer productivity. Python aims to enhance developer productivity by providing a clean and straightforward syntax, powerful abstractions, and a rich set of libraries. This allows developers to write code faster and with fewer errors, making Python a preferred choice for rapid development and prototyping. And the next is why is Python considered a general purpose programming language? A general purpose programming language is one that is designed to be used for writing software in a wide variety of applications domains. It is of the details related to memory management, hardware specifics, and system architecture. For example, you don't need to manually allocate and deallocate memory or worry about registers and memory addresses. Python's garbage collection automatically handles memory management for you. And the second reason is readable and concise syntax. Python syntax is designed to be readable and easy to understand. It uses indentation to define blocks of code, which enhances readability and reduces the need for explicit delimiters like braces. In other languages, here is the simple example comparing Python to C++. So the first C in the C++, we can write for int, or we can initialize the value 0, and we can give the condition statements, and the next is the increment, and the with braces we can open the increment like a count I, like that we can give. But if you want to use in Python directly, we can give for I in range is the function, the function with the function of range, if you give like that. And 5, the 5 integer I mentioned here, so it starts with the 0 1 2 3 4 and print I. So in this example, Python syntax is more straightforward and easier to read, especially for beginners. And the third reason is built-in data structures and libraries. Data structures like lists, dictionaries, sets, and tuples, which simplify data manipulation and reduce the need for manual implementations. Additionally, Python's standard library includes modules and functions for a wide range of tasks such as file IO, web development, and data analysis. This means you can accomplish more with fewer lines of code. Fourth reason is dynamic typing and interpreted nature. In Python, you don't need to declare the data type of variable explicitly. The interpreter infers the type at runtime, making the language more flexible and easier to use. Also, being an interpreted language, Python executes code line by line, simplifying the development and debugging process. And fifth reason is focus on developer productivity. Python aims to enhance developer productivity by providing a clean and straightforward syntax, powerful abstractions, and a rich set of libraries. This allows developers to write code faster and with fewer errors, making Python a preferred choice for rapid development and prototyping. And the next is why is Python considered a general purpose programming language? A general purpose programming language is one that is designed to be used for writing software in a wide variety of applications domains. It is not specialized for a special problem like a variety of a applications domains. It is not specialized for a specific problem or domain. Python fits this definition perfectly due to several reasons. Let's explore these reasons in detail. First reason is strong community and support. Python has a large and active community that contributes to its continuous improvement and provides support through forums, tutorials, and documentation. This community driven approach ensures that Python remains up to date with the latest trends and technologies, making it suitable for various applications. Reason 2 is platform independency. Python code can run on various operating systems including Windows, macOS, Linux, and more. This cross platform compatibility means that Python can be used to develop applications that work seamlessly across different environments without the need for significant changes. Why Python considered a dynamically typed language? A dynamically typed language is one in which the type of a variable is determined at runtime rather than the at compile time. In other words, you don't have to explicitly declare the type of your variable when you write your code. Instead, the type is inferred based on the value assigned to the variable at any point of time. Benefits of dynamic typing. Dynamic typing offers several advantages. First, flexibility. You can write more flexible and generic code. Functions and methods can operate on a variety of data types without needing to overload or create multiple versions for different types. Second, use of easy of use. It simplifies the code and reduces boilerplate, making it easier to write and read. You don't have to worry about declaring types or converting between them explicitly. Rapid prototyping, that is the third advantage. Dynamic typing is great for rapid development and prototyping. You can quickly write code and test ideas without being bogged down by type declaration. And the next is drawbacks of dynamic typing. While dynamic typing offers flexibility, it can also lead to runtime error that might have been caught at a compile time. In statically typed language, for example, operations on incompatible types might only be discovered when the code is executed. Potential runtime error x equal to 10. X equal to x plus have a concatenated with string. This will cause a type error at runtime. In this example, adding an integer and a string will raise a type error at runtime. Static type checking could have caught this error before running the code. And the next question is, what are the key features of Python? The answer is easy to read, learn, and write, interpreted language, dynamically typed, free and open source, extensive standard libraries, supports object oriented and functions programming, high level language, and portability. And third question is, what is the difference between .py and .pyc? The .py files are the Python source code files, while the .pyc file contain the bytecode of the Python files. .py files are created when the code is imported from some other source. The interpreter converts the source.py files to .pyc file, which helps by saving time. Next, sorry. What are the differences between Python 2 and Python 3? The answer is sorry. Print statement. Python 2 uses print as a statement. So this is the example, print hello. While Python 3 uses it to print of hello. Next, integer division. Python 2 perform integer division by default, while Python 3 performs true division. The next, Unicode. Python 3 stores string as Unicode by default, while Python 2 treats string as ASIC by default. X range function. Python 2 has X range for generating ranges efficiently, while Python 3 replaces it with range function. Next question is, what are the differences between interpreted and compiled languages? Answer is, interpreted languages are executed line by line at runtime, while compiled languages are translated into mission code before execution. Interpreted languages are typically easier to debug and platform independent, while compiled languages generally have better performance. What are the basic data types in Python? Answer is integer, float, complex numbers, strings, booleans, and nonce. If you want to in-depth of knowledge of basic data types, please watch my lesson 9 video. You can watch it and you can get to know the in-depth of knowledge on basic data types. And the sixth question is, how is memory managed in Python? Memory is managed in Python in the following ways. Memory management in Python is managed by Python's private heap space. All Python objects and data structures are located in a private heap. The programmer doesn't have access to this private heap. The Python interpreter takes care of this instead. The allocation of heap space for Python objects is done by Python's memory manager. The core API gives access to some tools for the programmer to code. Python also has an inbuilt garbage collector which recycle all the unused memory so that it can be made available to the heap space. Let's see what is garbage collector in Python. A garbage collector is a form of automatic memory management. Its memory purpose, sorry, its primary purpose is to reclaim memory that is no longer in use by the programmer, thereby preventing memory leaks and optimizing the value memory. In Python, the garbage collector is responsible for managing the life cycle of objects and ensuring that memory is efficiently allocated and deallocated. How Python manages memory? Python uses a combination of reference counting and cyclic garbage collector to manage memory. Here's how it works. Let's see how it works. Reference counting. Every object in Python has an associated reference count. This count tracks how many references are pointing to the object. When the reference count drops to 0, the memory occupied by the object can be safely reclaimed because no part of the program is using it. For example, x equal to 1, 2, 3, there is a list here. So the y equal to x, the list object now it is the change it to y. Now I am deleting del x. So what happened? It is reference count for list object is now 1 and del y. So reference count for list object is now 0. So the memory can be reclaimed. Let's see what is the cyclic garbage collector. Reference counting alone cannot handle cyclic references, where two or more objects reference each other. creating a cycle. The cyclic garbage collector periodically checks for such cycles and breaks them to reclaim memory. For example, a equal to this is the empty list. So now I'm storing into b, though this a empty value it store into b. Now I'm appending a dot append of b, so both a and b reference each other, creating a cycle. And the next is the, as I told the previous, the same thing I have given here the separately, because the you should know the clear understanding. And next is how the garbage collector works. Python garbage collector works in three main steps. The first step is tracking. The garbage collector keeps track of all objects in memory. It maintains a list of objects that might be part of a reference cycle. And the second, detection. It periodically runs a detection algorithm to identify group of objects that reference each other but are not reachable from any root object, that is global variable stack frames. And the third is collections. Once a cycle is detected, the garbage collector breaks the cycle by reclaiming the memory occupied by the objects involved in the cycle. And next is the Python garbage collector is the part of the GC module, which provides an interface for interacting with the garbage collector. You can manually trigger garbage collector collection. You can manually trigger garbage collection, adjust its behavior, or even disable it if necessary. If you want to see the garbage collector, let's see how much is collected. So import GC, you should give this module, you should import this module and manually trigger garbage collection GC dot collect. This is the function. With this method, you can check the get the current garbage collector thresholds. GC print of GC dot get underscore threshold. This is the method you can see. And the seventh question is explain mutable and immutable in Python. Mutable objects can be changed after they are created. For example, list, dictionaries. And while immutable objects cannot be changed, that is tuples or and strings. What are the differences between set and list in Python? Sets are unordered collection of unique elements, while lists are ordered collection of elements. Sets don't allow duplicate elements, while lists do. What is slicing in Python? The answer is slicing is used to access the part of sequences like list, tuple, and strings. So this is the syntax starts end step. The step can be omitted as well when when we write start end. This retains all the elements of the sequence from the start inclusion till the end minus one element. It should not include the end value. It should display end minus one element. If the start or end element is negative, it means that ith element from the end. The step indicates the jump or how many elements have to be skipped. For example, if if there is a list 1 2 3 4 5 6 7 8, then minus 1 colon 2 colon 2. So now the start index is minus 1. So it will come from the last, like from the end. And 2 is the step and end is the 2. So we'll return elements starting from the last till the third element by printing every second element. So output is displayed 864. And the next question is explain dictionaries in Python. Dictionaries are unordered collections of key value pairs. Keys must be unique and immutable. For example, strings, tuples. While values can be any data type, dictionaries are represented by curly braces. And tenth question is what are control flow statements in Python? Control flow statements are used to control the flow of execution in Python program. For example, if else statements, loops, exceptions. What is a conditional statement in Python? A conditional statement allows a program to execute different code based on certain conditions. For example, if, and else state. Thanks for watching. Please continue next video because this video is unable to do the single video. So please watch the next video also to continue the 50 top interview theoretical questions and answers. Please subscribe if you like this video, and give comments to get more interview questions, and what are your questions also. Please post in comment. Thank you.